All right, this will be the Transitional Algebra Chapter 1 review. All right, y'all. So for number 1 here, they want me to determine whether the given number is a solution of the given equation. So they're giving me -8, semicolon. So -8 is the number they want me to check. And the equation is 2y minus 4 equals -19. So if -8 is going to be a solution of this, when I plug -8 in for the y and work that left side, I need to get a -19. If I get any other number, then it's not a solution. So let me plug in that -8 and then bring down my -4, and that's got to equal -19. All right, let's see. 2 times -8 is -16 minus 4 equals -19. And you know, when we do the left side, -16 minus 4 gives me a -20 equal to -19. So that is a false statement. So since that's a false statement, that means -8 is not a solution. So that would be no. Question 2, solve using the addition principle. So they're giving me -28 equals x minus 13. So the addition principle means I need to add to each side to solve this equation. So what I want to do is get this x by itself. So since this 13 is being subtracted, to make the 13 disappear on the right side, I got to add 13, which means I got to add 13 to the left side. So -28 plus 13 gives me a -15 equal to, all these 13s canceled on the right side. All that's left is our x. So that means x equals -15. 3, solve using the multiplication principle. They're giving me -10z equals 40. So the multiplication principle also applies to division. So what I want to do is get that to be a 1z instead of a -10z. So anytime you got a number being multiplied by your variable, you're going to divide by that number on both sides. So that this -10 divided by -10 makes that a 1. So I now have a 1z on the left side. I'm dividing unlike signs, so that's going to be a negative. And then 40 divided by 10 gives me a 4. So if you just check it, -10 times -4 equals a positive 40. All right, number 4 says solve using the multiplication principle again. Don't forget to check. So they got a 8/3 x equals a -1/6. So basically, since there's an 8/3 here in front of my x, I would divide by 8/3. But remember, when you divide by fractions, you take the second fraction, flip it, and change this to multiplication. So the 8/3, its opposite will be a 8/3, a 3/8. So I'm going to multiply both sides by 3/8. So that'll equal my 3/8 times my -1/6. So notice on this side, the 3's cancel, making a 1. The 8's cancel, making a 1. So the left side, 1 times x is just the x. Now the right side, I'm going to reduce before I multiply, because 3 and 6, both of those will divide by 3. So if you divide 3 by 3, that becomes a 1/8. If you divide the 6 by 3, that becomes a -1/2. So now I'm going to multiply this. 1 times -1 is a -1. I had an 8 on the bottom, times that 2 gives me 16. Now, y'all, you could have also did 3 times -1. You could have got a -3. And then you could have did 8 times 6 and made that a 48. But that -3 over 48, if you divide the 3's out, that'll still give you a -1 over 16. So you can reduce before you multiply like I did, or you can multiply first and then reduce. All right, 5 says solve using the principles together. So I'm going to be adding and subtracting and then dividing or multiplying. So they're giving me 8x plus 13 equals a -27. So you want to get the x by itself on the left side. So since that's a plus 13, we need to subtract 13 from both sides. So I'm going to get my 8x. 13's cancel. And that's going to equal -27 plus -13 is a -40. Now, I need to turn the 8x into a 1x. So I'm going to divide both sides by the 8. So 8 divided by 8 gives me a 1 again. So I get a 1x. Negative divided by positive is going to be a negative. And then 40 divided by 8. So I get a -5. All right, 6 wants me to solve using the principles together again. But this time they're giving me a 4/3 x plus a 2 over 6 x equals a 50 over 6. So anytime I got an equation like this that has 3 fractions in it, I try to get rid of the fractions. So what you want to do is look at this denominator. You got a 3, a 6, and a 6. The smallest number that a 3 and a 6 will go into is a 6. So it's like finding the least common denominator. So since the least common denominator between 3 and 6 is 6, I'm going to multiply all 3 of these by the 6 to get rid of my fractions. So I'm going to do 6 times my 4/3 x plus 6 times 2 divided by 6 over x equals 6 times my 50 over 6. Now remember, when you multiply and divide, you got to do it to every single part of that equation. All right, so the reason we did that, this 6 will divide by that 3, making that a 2. So now we got 2 times 4x, which is 8x, plus in the middle, that 6 cancels with that 6, making that a 1. So I got 1 times 2x, which is 2x. And then on the right side, the 6's cancel, making a 1. And 1 times 50 is 50. So we got rid of all the fractions. So our next step on this left side, x's add to x's because we got like terms. So since they're on the same side, all we're going to do is add them together. So 8x's plus 2x's gives me 10x's equal to 50. So now, turn the 10x into 1x by dividing both sides by that 10. So I got 10x divided by 10 is going to equal 50 divided by 10. So y'all, these 10's cancel, making a 1. So I got 1x equals 50 divided by 10 gives me a 5. All right, y'all, so let's see. I'm going to turn my page and we'll do number 7. Seven again, solve using the principles together. I got 7x plus 52 equals 2x minus 13. So what I want to do on this one, I'm going to get the x's on this left side, all the numbers on the right side. So to start out, I need to move to 2x. Since it's positive, I'm going to subtract 2x. So basically, if you want to move something from one side to the other, change the sign. If the 2x is positive on this side, it's going to become negative on the other side. So y'all, 7 minus 2 gives me 5x plus my 52 equals, well, them x's cancel. So all that's left is the negative 13. So when you got subtraction, if you get rid of the number in front of it, it becomes a negative for that number, okay? All right, so now we want to get to 5x by itself. So we're going to move the number by subtracting 52 from both sides. So y'all look, my 5x comes down. 52's cancel on the left side. Over here, I'm adding two negatives. So it's going to stay negative. And that's going to be what? A negative 65. Remember, when you add like signs, they stay that sign, okay? All right, that's 5x. I need to turn that into 1x. So I'm going to divide both sides by the 5. So that cancels, giving me a 1x again. Negative 65 divided by 5 gives me a negative 13. All right, y'all, let's see. Solve using the principles together. So we got negative 13 plus 4x equals 4x minus 13. All righty, so let's see what we got to do. I'm going to get the x's on one side, numbers to the other. So I'm going to move the 4x by subtracting. All right, y'all, so bring down the negative 13. Uh-oh, these x's canceled on the left side. These x's canceled on the right side. And I got negative 13 equals negative 13. Remember, when you got a number equal to a number, that is a true statement. So since that's a true statement and I got a number equal to a number, for number 8, the solution would be all real numbers. Okay, so remember, if that variable's gone and you get two numbers equal to each other and it's true, it's all real numbers. Now, y'all, let's see what number 9 has. 6y minus 11. And the same thing, solve using both principles. This is going to equal 12 plus 6y. All righty, so once again, I want all my variables on one side, numbers on the other. So I'm going to start by subtracting this 6y. But y'all, look what's happening again. 6y is canceling on this side. I got negative 11. That's going to equal that 12. Those y's cancel. So since my variable canceled like it did up here, but look, I got negative 11 equals 12. That is a false statement. So since that's a false statement, this would be no solution. So there is no solution. So y'all watch out for that 8 and 9, okay? All right, number 10, solve using the principles together. I got 84 equals 12 times parentheses 2y plus 3. All right, so the thing we got to remember, 2y and 3 do not add together. So the first thing, to get rid of these parentheses, I need to multiply that 12 by the 2y, and then I need to multiply that 12 by that 3. So bring down your 84. That's going to equal 12 times 2y is 24y. And then 12 times a positive 3 is a positive 36. So we need to get this y by itself. So I'm going to move that positive 36 by subtracting 36 from both sides. So y'all, let's see. 84 minus 36. That's going to give me 48. That's going to equal a 24y. And those 36s cancel. All right, so we need to turn 24y into 1y. So we're going to divide both sides by 24. So 48 divided by 24 is 2. And that's going to equal, well, 24 divided by 24 is a 1. So that's going to give me 1y. And y'all remember this. When we're not putting a number in front of that y, it's understood to be a 1 there, okay? All right, 11. Solve using the principles together again. I got an 8y minus parentheses 2y minus 17. That's going to equal 41. So we can't add like terms because we got parentheses. So we got to get rid of these parentheses first. So since there's not a number in front of the parentheses, we're going to treat this like a -1 here. So remember, that subtraction is like a -1 when I want to get rid of these parentheses. So I bring down this 8y. Then I'm going to multiply that -1 times that 2y. So you got to distribute the negative also. So negative times a positive makes that a -2y. That -1 times that -17. That's like signs. So that's going to make that a positive 17. And then that's going to equal or 41. Now, since my parentheses are gone, I can add the like terms right here. So 8y and a -2y give you 6y plus 17 equals 41. All right, y'all, so here's what we need to do. We need to get the 6y by itself. So we're going to subtract 17 from both sides. That's going to give me my 6y. Those 17s cancel. And 41 minus 17 gives me 24. And y'all, my last step, divide 6y by 6. Divide the 24 by 6. And let's see, our final answer, that's going to give me a 1y. 24 divided by 6 gives me 4. All right, y'all, let's start with number 12. So the trick on these last few equations is getting rid of those parentheses first, okay? So now, solve using both properties. So this was the big one. 7 times 5x plus 9 in parentheses equals 12 minus x plus 9 in parentheses. So parentheses on each side. So over here, I'm going to distribute that 7 through these parentheses. Over here, I'm going to treat that like a -1 again and distribute the -1 through the parentheses. This 12 ain't in parentheses, so it is not affected, okay? All right, here we go. 7 times 5 is 35x plus 7 times 9 is 63. That's going to equal 12. -1 times x is a -1x. -1 times 9 is a -9. All right, at the moment, nothing I can do on the left side, but y'all on the right side, you got a 12 and a -9. That 12 and -9 are like terms. So I'm going to bring down to 35x plus 63. The 12 added to a negative 9 makes that a 3, and then bring down your negative x. All right, so what I want to do over here, I'm going to get these x's on the left side, these numbers on the right side. So to move that x, you're going to add x to both sides. And notice, I'm only adding x's to the other x's, okay? So 35x's plus an x is 36x plus 63 equals my 3, and then them x's canceled out. All right, y'all, so let's see what we got going on now. Got the x's over here. I'm going to subtract 60 from both sides. I mean, subtract 63, my bad. So 36x comes down. 63's cancel. Over here, 3 and a negative 63 is going to give me a negative 60. All right, y'all. So now 36x's, I want to turn that into 1x. I'm going to divide both sides by 36. So that I get my x, because that gives me what, a 1x. Over here, I'm going to bring down that negative. So 60 divided by 36, I can't do, so I'm just going to reduce this fraction. 60 and 36, the largest number they'll divide by is a 12. So I'm going to divide both these by 12. So that's going to give me a negative. 60 divided by 12 is 5. 36 divided by 12 is a 3. Now, MathLab wants us to leave this as an improper fraction. So you don't have to turn that into a negative 1 2/3 or anything like that. Now, y'all remember, if you're not good at reducing fractions, on your calculator, do negative 60 divided by 36. That'll give you a decimal. To turn that decimal back into a fraction on the calculator, you hit math and then enter and enter. So when you go to math and hit enter, the first thing you see is a fraction with an arrow. That means it'll turn your decimal answer into a fraction. So you hit math and enter, and then you hit enter one more time, and it does the fraction. All right, y'all. So let's see. I'm on 13 now. So 13 says solve for m. So they're giving me S equals 3m plus 3w. They want me to solve for the m right here. So to solve for m, I need to get the 3m by itself. So we're going to subtract 3w from both sides. So these are not like terms. So you're going to get a s minus 3w equals 3m, and then the w's cancel. All right, so I got 3m, but they want me to make that an m. So what I'm going to do, divide both sides by 3. So s minus 3w divided by 3 equals 3m divided by 3. Now, y'all, here's the thing. On this side, since there's not a 3 with the s, you cannot cancel these 3's out. Okay? You got to be able to cancel out of all 3 of these in order to cancel this 3. But you can't do that. So this left side will stay s minus 3w over 3. The right side, the 3's cancel, making that a 1. So that's going to leave me 1m. So m is going to equal s minus 3w divided by 3. 14 says solve for J. They're giving me F equals 1/2 J times Q. All right, so to solve this for the J over here, the first thing I'm going to do is get rid of this fraction. To get rid of that fraction, I'm going to multiply both sides times 2. All right, so over here, nothing happens. 2 times F is 2F. On the right side, those 2's cancel, making that a 1. So I got 1 times 1, which is 1. 1 times JQ is a JQ. All right, so since this J is being multiplied by the Q, to make that a 1J, I got to divide both sides by the Q. So I got 2F divided by Q is going to equal my JQ divided by Q. All right, over here, 2F divided by Q, I cannot do anything with. But y'all over here, these Q's cancel, making a 1, and J times 1 is a J. So that means J equals 2F divided by my Q. All right, y'all, let's see. 15 wants me to write X such that X is less than or equal to 4. They want me to write that in interval notation. So interval notation is where I use curvy parentheses and those infinities. So notice, X has to be less than 4. So the largest number is a 4. So that 4 is going to be on the right side. But I got to figure out what all numbers are less than or equal to that 4. So those will be numbers like 3, 2, 1, 0. And notice I can go left as far as I want to find numbers that are less than 4. So we say X less than 4 in interval notation will be from negative infinity. Because remember, I can keep subtracting and get lesser and lesser. And then 4 is the largest number it can be. Now remember, since it's got that equals under it, I have to use a square bracket. That means it includes that 4. So if you put a 4 in here, 4 less than or equal to 4, that's true because of that equals. So that's why the 4 has a bracket around it. If that was just a less than, then I'd have just used a curvy parenthesis. All right, remember, negative infinity or infinity, they always have curves because they're not an exact stopping point on those, okay? So y'all, let's try another one of these. We're going to write parentheses X such that -6 is less than or equal to X, which is less than 6. So notice on this one, the X is in between two numbers. So the leftmost number is a -6. The rightmost number is a +6. I just got to figure out whether I'm using parentheses or brackets. So since the -6 has a less than or equal to X, the -6 will have a bracket around it. And then over here, this +6 has just a less than. So since it does not have an equals under it, the +6 gets a parenthesis. All right, number 17, I'm going to put me a picture up here for it. And I'm going to zoom in for this problem. All right, so we got a right interval notation for this graph. So this graph has a bracket at 3, and then it heads right, being shaded, and it keeps on going because there's an arrow there. So the smallest number is 3. When this arrow keeps on going to the right, we say it's headed towards positive infinity. Now, since they got a bracket on that graph, that means my 3 will have a bracket. And remember, infinity always has a curvy parenthesis. So we want the one over here that's got the bracket 3, comma, infinity with a parenthesis. Y'all be careful because the other one's got 3 and infinity, but they got both brackets on this one and both parentheses. We need the one with a bracket and a parenthesis. So on that one, you would pick something like A, okay? All righty. All right, so I'm going to unzoom again, get my paper back. All right, so that was 17, so this will be 18. They want us to solve and graph. They're giving me t plus 18 is greater than or equal to a 2. So t plus 18 greater than or equal to 2. I need to get the t by itself by subtracting 18 from both sides. So I bring down my t, 18's cancel, bring down my greater than or equal. 2 minus 18 is a negative 16. So that is our solution. So they'll have you put the solution is t such that t is greater than or equal to negative 16. Pick the one with the greater than or equal. And then on the graph, so let's see. I'm going to start with my negative 16 in the middle since that's the number I got. And this way would be negative 15, negative 14, negative 13, and so on. Left would be negative 17, negative 18, negative 19, negative 20, and so on. So greater than or equals negative 16. Remember, greater than, that's pointing right. So I'm going to be shading to the right. So negative 16, since that's got an equals, I got to use a bracket. And then, like I said, greater than shades to the right. And y'all, if you keep the variable on the left side, this will always point the way you got to shade your line, okay? All right, 19. Same thing on this one, I just got to solve it. I just got to solve 6x plus 3 is less than 45. So this one I don't have to graph. I just got to solve it. So I'm going to get this 6x by itself by subtracting 3. So I get my 6x. Those 3's cancel. And that's less than 45 minus 3 is 42. All right, we want to turn the 6x into a 1x. So we're going to divide both sides by 6. So those 6's cancel, making a 1x less than 42 divided by 6 is 7. Now remember, if I would have divided by a negative number, I would have had to flip my inequality, okay? All right, let's see what we got on 20. 20 has 6y plus 4y less than or equal to a negative 40. So I got like terms on the left side. So since the y's are together on the left side, I'm going to add them together. 6 plus 4 give me 10y less than or equal to my negative 40. All right, y'all, make that a 1y by dividing both sides by 10. Once again, that gives me a 1y. I don't flip that because I'm dividing by a positive 10. And then here we got negative divided by positive. We'll make that a negative. 40 divided by 10 is a 4. All right, y'all. So flipping the page for number 21. All right, solve the following inequality. I don't have to graph this one either. So I got 2y minus 3 is less than 8y minus 4. All right, so I need the variables on this side, and then I'm going to get the numbers on the other side. So I'm going to move the 8y by subtracting 8y. All right, so 2y minus 8y gives me negative 6y minus my 3 is less than. Those y's cancel, so all that's left is my negative 4. Now, move the number to the other side by adding 3. So if you notice, I bring down my negative 6y. My 3's cancel, so that's going to be less than. Negative 4 and 3 is a negative 1. So y'all, my variable is negative this time. So to make that a positive 1, I'm going to have to divide both sides by that negative 6. Now, since I'm dividing by negative, I'm going to take that inequality and make that less than into a greater than. So I do have to flip it now because I divided by the negatives. All right, these 6's cancel, making a positive 1y. That's going to be greater. Negative divided by negative is a positive, and 1 does not divide by 6, so that's going to stay a 1 over 6. Okay, so just remember, when you divide by the negative is when you reverse your little inequality around, okay? All right, y'all, so the last 4 of these are solving by elimination method. X plus 2y equals 13. Negative x plus 4y equals 17. Well, this one's obvious. I'm going to cancel the x's first by elimination because I got a positive x and a negative x. So by adding, those cancel. 2y plus 4y gives me 6y. 13 plus 17 gives me 30. So the x is eliminated. So to solve that for the y, we're going to divide both sides by 6. So that cancels, giving me a 1y. 30 divided by 6 is 5. So now that I know the y is 5, I'm going to plug it into this first equation and solve it for the x. So I'm going to have x plus 2 times y, which is 5, equals 13. All right, y'all. So first thing you got to do is multiply that. So that'll give you x plus 10 equals 13. Subtract 10 from both sides to get the x by itself. And I get my x. 10's cancel. 13 minus 10 gives me 3. Now remember, these answers got to be in the form of an ordered pair. So you got to put them in parentheses. And then the x goes first, which is 3. Then the y goes second. Remember, you got to have them in alphabetical order. So put the 3 first and then the 5. And then remember, they got to be in parentheses, okay? All right, 23, solve by elimination. 3x plus 3y equals negative 6. 9x minus 3y equals negative 42. All right, so looks like I'm going to cancel the y's because I got a plus 3y and a negative 3y. So let's see. I don't have to change anything. 3x's plus 9x's is 12x's. 3y, negative 3y cancel. Negative 6 and negative 42 give me a negative 48. All right, so all I got to do is divide both sides by 12, and I'll know what my x equals. So that cancels, making a 1x. Negative 48 divided by 12 will be a negative 4. So y'all, I know what my x is equal. So I'm going to plug the x in right here and solve it for that y. So I got 3 times negative 4 plus 3y equals negative 6. Once again, you got to multiply first. 3 times negative 4 is negative 12 plus 3y equals negative 6. Now I want to get the 3y by itself, so I'm going to add 12 to both sides. So that gives me my 3y, because those 12s cancel. Negative 6 plus 12 is a positive 6. And y'all, our last step, divide both sides by 3. So that's going to cancel, giving me my 1y. 6 divided by 3 gives us 2. So on that one, we need the x first, which was negative 4. The y, which was 2. And put those in parentheses. All right, y'all. So I'm going to go to my next page for my last two, okay? So this will be 24. And let me get my camera moved back up. All right, so we're down to 2. So 24, solve the following system of equations by elimination. 5r minus 3s equals 19. 2r minus 6s equals negative 2. All right, so this one's not as clear cut about canceling any of my variables out, but I got a 5 and a 2, so I would have to change both of those to probably a 10 and a negative 10. But over here, I got a 3 and a 6. So 6 is a number that 3 will go into. So I'm going to try to turn this negative 3 into a positive 6, since this row's got a negative 6. So if I don't make that negative 3 a positive 6, I'm going to take this top row and multiply everybody by negative 2. Because a negative 2 times a negative 3 will make that a positive 6s. So y'all, let's distribute the negative 2 through the first equation. Negative 2 times 5 gives me a negative 10r. Negative 2 times negative 3 gives me a positive 6s. And then negative 2 times 19 gives me a negative 38. Then I'm going to bring down the second equation. 2r minus 6s equals negative 2. All righty, so now my s's are going to cancel. So negative 10 plus 2 give me negative 8r. S's cancel. Negative 38 plus a negative 2 is a negative 40. So once again, I'm adding 2 negatives, so the answer stays negative. Now, divide both sides by the negative 8, because we want this to be a 1r. So that cancels, giving me a positive 1r on the left side. I'm dividing like signs, so that's going to be a positive answer. And then 40 divided by 8 gives me a 5. So I now know this r is 5. So I'm just going to plug 5 into my first equation. So I got 5 times r, which is 5, minus 3s equals 19. All right, so first you got to multiply again. So that's going to give you 25 minus 3s equals 19. Get the negative 3s by itself, so subtract 25. And y'all watch this. The 25s cancel. Bring down the negative 3s. 19 and negative 25 give you a negative 6. All right, then we need to turn the negative 3s into a 1s. So divide both sides by -3. So -3 divided by -3 makes that a 1s again. And that 1s, negative divided by negative, makes that a positive. 6 divided by 3 is a 2. So remember, ordered pair for the answer. So let's see, I got R and S. So alphabetical order would be the R first, which is 5, comma, the S, which is 2. And y'all, then there was 1. Solve by the elimination method. 3x minus 9y equals 2. 3x minus 9y equals 3. So the x's are both 3's positive. The y's are both 9's negative. So I can eliminate either one of them variables. So I'm going to eliminate the x's. So if I want to eliminate the x's, I need to make one of these x's negative. So what I'm going to do is take this second row and multiply all these by a -1. By multiplying this row by -1, I can make that 3x into a -3x. So y'all, my top row is staying the same. 3x minus 9y equals 2. Now, my second row, I'm going to distribute that negative to all three of those. So -1 times 3 is a -3x. -1 times -9 is a positive 9y. That's going to equal -1 times 3, which is a -3. Now, you could have multiplied the first row by the negative and made that a -3x plus 9y minus 2. It didn't matter which one you multiplied by the negative, okay? I just usually multiply my second one because I like to keep that first row sort of positive, but it don't matter on these. But look, 3x, -3x cancels. But look here, the -9y and 9y cancels. So since everything canceled on the left side, all that's left is a big 0. Well, that's going to equal 2 added to a -3 gives me a -1. Uh-oh, y'all. So when you get a system of equations and you get something like this, 0 equals -1, that's false. That means this is a no solution. Now, if I would have got 0 equals 0 or -1 equals -1, that would have been a true statement. Then that would have meant there were infinitely many solutions. But since that was false, we have a no solution. So y'all, that is your chapter 1 review. Remember, you can work the chapter review as many times as you want to get ready for my test. Now, I say that because you only get one chance on this test, okay? One shot is it. So do good. That's why you got to do that review as many times as you got to get good at it. Now, the review and the test will be in the same order, same type questions. So I'm not going to throw no curveballs at you. Okay, so get good on your review, then knock out my test. So I'm going to stop sharing my screen. And y'all, I'm going to stop my video and good luck.